Hello everyone, welcome to PM Networking. Guys, today I am going to create one more playlist on my YouTube channel, and name of this playlist is STP. STP stands for Spanning Tree Protocol. Spanning Tree Protocol means in this playlist, in this series, we will discuss everything about a spanning tree protocol, like types of STP. As you know, we have several types of a spanning tree protocol, like CST. First one is CST, second one is PVST, third one is PVST plus, fourth one is RPVST plus, fifth one is RSTP, sixth one is MST. So we will discuss these 6 types of a spanning tree protocol in this series. We will also understand topology change in a spanning tree protocol, what are the states in STP, what is the election process of root bridge, election process of designated port, root port, everything in this series. Okay, so this is day 1. Today we will discuss very basic things about a spanning tree protocol, like why we come up with a spanning tree protocol. So STP is a layer 2 protocol which is used to avoid layer 2 loop, which is used to prevent, or you can say avoid, layer 2 loop. So first of all, we will discuss how layer 2 loop can form in topology, right? Then we will understand how STP works. After that, today we will discuss what is the election criteria of root bridge, what is the election criteria of root port and designated port. Okay, so without wasting our time, let's begin, guys. See here in this topology, here in this topology, as you can see, we have 3 switch 1, switch 2 and switch 3. All switches are directly connected with each other. So topology is in circular. There is one redundant link, there is one backup link, right? So if computer C wants to communicate with computer B, switch 3 have 2 paths, right? Switch 3 can forward traffic to switch 2 also, and switch 3 can forward traffic to switch 1 also. Means computer C can communicate via switch 1 also, and they can communicate via switch 2 also, right? So we have 2 paths. So if this path will goes down, they can communicate via this path. If this link will goes down or this link will goes down, they can communicate by using this link. So there is backup. But whenever there is redundant path in your topology, layer 2 loop can be formed. See how? Whenever any machine will generate broadcast message, do you know how switch will treat broadcast message? So rule is, the function of switch is, whenever switch will receive broadcast message on any interface, whenever switch will receive broadcast frame. So when this machine will generate broadcast frame, by the way, suppose IP address of computer C is 10.0.0.3 and IP address of computer A is 10.0.0.1. Now if 10.1 wants to communicate with 10.3, 10.1 need MAC address of 10.3. This computer have to resolve MAC address of this computer. So basic requirement for communication is source IP, destination IP, source MAC and destination MAC, right? These 4 components are basic requirement for communication. So to resolve MAC address, what this machine will do? This machine will generate ARP request. ARP request, address resolution protocol. And as you know, ARP is an broadcast message. ARP is an broadcast frame. So whenever any machine will generate ARP or any broadcast message, what switch will do? So function of switch is, whenever switch will receive broadcast message on any interface, when switch will receive broadcast message on this interface, suppose on 0/2, or you can consider on this interface. So whenever switch will receive any broadcast frame on any interface, first of all switch will learn source MAC address. First of all, definitely switch will learn source MAC address. As you know, switch maintain MAC address table to forward traffic. MAC address table, right? In their table they will make one entry that on my 0/0, 0/2 a device is connected with MAC address is C, and this port is member of which VLAN 1. This is MAC address table of switch 3. After that, switch will check destination, and if destination is broadcast, so switch will forward broadcast frame from all of its active interface except the interface on which frame was received. मतलब जिस पोर्ट पे रिसीव हुआ था उसको छोड़ के बाकी के सारे पोर्ट से क्या करेगा, भेज देगा. Yes or no? So whenever switch will receive any broadcast frame, it will forward to its all interface except the interface on which frame was received. So when switch 3 will receive any broadcast message from PCC, switch 3 will forward to switch 1, and switch 3 will forward to switch 2 also. Leave it for a minute. Let me discuss about this packet, about this broadcast packet. So whenever switch 3 will receive any broadcast frame, switch will forward to switch 1. What switch 1 will do? Switch 1 will also forward from this interface and to this interface also. It will forward from its all active interface except one interface on which frame was received. So when switch 2 will receive that broadcast message, switch 2 will also forward to switch 3, and again switch 3 will forward to switch 1, then again switch 1 will forward to switch 2, to switch 2 will forward to switch 3, and your broadcast message will be moving in this network for very long time, for lifetime. And same thing will happen in opposite direction as well, right? When switch 3 will receive broadcast message, it will forward to switch 2 also, switch 1 also, and switch 2 also. Switch 2 will forward to switch 1, switch 1 will forward to switch 3, then again switch 3 will forward to switch 2. Yes or no? So in both direction broadcast frame will be moving for lifetime because there is no TTL in layer 2 header. So this is known as loop. This is how loop can form in topology when we have redundant path. So if you want to avoid this loop, what you can do, you can shut down this link, you can remove this link from this port, right? Or you can shut down any port, this port or this port, or you can shut down this port as well, this port as well, right? Any port, so that loop can be not formed. So loop can be not, ताकि loop form नहीं हो सकता है, क्योंकि because if your topology is in linear, then loop can never form. Because suppose if I will remove this link, and now if switch 3 will receive one broadcast frame on this interface, switch 3 will forward to switch 1, switch 1 will forward to switch 2. How switch 2 can forward to switch 3? Because link is not available between switch 2 and switch 3. But is it possible to remove this link? Right? Because if you will remove this link, and whenever this link will goes down or this link will goes down, there is no redundancy, there is no backup, so this user cannot communicate with each other. Yes or no? This user cannot communicate with each other, so we need backup. We need what? Backup link. So whenever my primary link will goes down, my traffic should go via backup link. But if you will connect backup link, if you will connect link between switch 2 and switch 3, there is problem of loop, problem of layer 2 loop. So, and see second problem. This is first problem. Second problem is MAC flapping. MAC flapping. What will happen? What is MAC flapping? Whenever switch receive the frame from two interface or from more than one interface with the same source MAC address, that is known as MAC flapping. So when PCC will forward one broadcast traffic to switch 3, switch 3 will learn source MAC address on which interface? On 0/2. MAC address is C. MAC address is C. After that it will forward to switch 1 and switch 2. When switch 2 will receive this broadcast frame on this interface, switch 1 will also learn MAC address on 0/1. MAC address is C. Right? In the same way, switch 2 will learn MAC address on which interface? MAC address C on this interface, that on 0/1 MAC address is C. And after some time, switch 2 will receive same broadcast message on this interface also, right? So it will run same MAC address on 0/0. After some time, it will remove previous entry. But whenever switch will learn same MAC address on multiple port, that is known as MAC flapping. MAC flapping. So switch will give you error of MAC flapping on interface F0/0 or on interface 0/1. So to avoid these two problems, we come up with STP, with a spanning tree protocol, because it is not possible to remove this link again and again. Whenever these two links are up, you have to remove this link, and when any link from these two link will goes down, you have to connect this link again, right? It is not possible. So we have a spanning tree protocol. Now understand what STP spanning tree does. Spanning tree करता क्या है? So a spanning tree prevents loop by placing each switch port in either a forwarding state or a blocking state. So STP will avoid this layer 2 loop by placing switch port either in forwarding state or in blocking state. So what STP will do? STP will put these all ports either in forwarding state or in blocking state, and interface in forwarding state act as normal interface, act as normal port. So suppose the state of this port is forwarding, right? Forwarding. So this port will act like a normal port. This port can send traffic as well, this and receive traffic as well. So switch can forward and receive frame from the interface whose state is in forwarding, and the port whose state is blocking, right? So interface in blocking state do not process any frame except STP message. So blocking port cannot process any frame. Blocking port can only receive STP message, like STP BPDU. Fine. So suppose this is my blocking port. So this port cannot receive frame, any frame of user, any broadcast message. This port can only receive STP message. So blocking port will not use to forward or receive frame, or you can say data, right? Frame or data. Now suppose according to STP this port is in blocking state. If STP will block this port, and STP will keep track of redundant path as well, right? So whenever your active link will goes down, STP will up this link. STP will change the state of this port from blocking to forwarding. So now if a state of this port is forwarding, so this port can forward frame, or this port can receive frame as well. Yes or no? Yes. So see what STP will do. Suppose STP will block this port. Now if computer C will generate broadcast message, that broadcast message will receive by switch. Switch will learn source MAC address on this interface. After that switch will forward to switch 3 will forward to switch 1 only. It will not forward to switch 2 because state of this port is blocking, right? And from blocking port switch cannot send frame. When switch 1 will receive broadcast frame, switch 1 will forward to switch 2. Switch 2 will forward from this interface. Switch 2 will out from this interface, but switch 3 will not receive. Switch 3 will ignore that broadcast message because a state of this port is blocking. Fine. A state of this port is blocking. So loop cannot form here now, right? And switches cannot learn same MAC address on multiple port as well. So there is no problem of MAC flapping. There is no problem of loop. Now loop cannot form in this topology. So my logical topology is what STP is doing. STP is creating logical topology, logical loop free topology from physical loop topology. So according to STP topology is like this. This is my switch 1, this is my switch 2, and this is my switch 3. Like this. This is my logical topology. Or topology can be like this also. Switch 1, switch 2 and switch 3. Topology can be like this also. Topology can be like this also. Switch 1, switch 2 and switch 3, right? So STP can design 3 loop free topology with the help of this physical topology, loop free logical topology from this physical topology, right? And suppose STP topology is this one, switch 1, switch 2 and switch 3, like this, right? And whenever this link will goes down, what STP will do? STP will have track of blocking port. It will change the state of this port from blocking to forwarding. Now this port will use to forward and receive frame. So now logical topology is this one, switch 1 like this, yes or no? Okay, so now we are going to discuss how STP will block one port. So to block redundant path or backup path, what STP will do? First of all, STP will elect one switch as root bridge, one switch as root bridge. STP will elect one switch as root bridge. Now question is, what is root bridge? So root bridge is a reference point in topology. You can say root bridge switch is main switch in topology that will control the entire topology, that will control the entire layer 2 network. Fine, that will control layer 2 network. Root bridge switch will decide that which port state will be in forwarding and which port state will be in blocking. Who will decide? Root bridge switch. So always keep in mind, first step is to avoid loop is enable STP, and what STP will do? STP will elect one switch as root bridge, one switch as root bridge. So now question is, which switch will become root bridge? So switch which will have lowest bridge ID, lowest bridge ID. Now again question is, what is bridge ID? Now again question is, what is bridge ID? So suppose MAC address of this switch is 0A, MAC address of this switch is 0B, and MAC address of this switch is 0C. MAC address of this switch is, these are base MAC address of switches, right? These are base MAC address of switches. So every switch has one base MAC address. Okay, so suppose base MAC address of switch 1 is 0A, base MAC address of switch 2 is 0B, and base MAC address of switch 3 is 0C. And bridge ID is an 8-byte value, 8 bytes values, right? 8 byte का क्या है? एक value, bridge ID. And bridge ID is combination of two things. First one is priority, and second one is base MAC address, base MAC address. Priority plus base MAC address. What is bridge ID? Bridge ID is combination of two things, priority plus base MAC address, and priority is 2 byte value, 2 bytes value, and as you know MAC address is 6 byte values. So total size of total size of bridge ID will be 8 byte, 2 byte priority plus 6 byte base MAC address, right? So let me discuss some more about priority. Priority is 2 byte value, 2 bytes value, that means 16 bits value. So how many priority are there? How many value are there in priority to the power 16? It will be 65536. In range it will be 0 to 65535, right? Range of priority. And by default priority on switches is, by default priority is configured on switch is 32768, 32768, 32768. So on every switches by default priority is 32768. So what will be the bridge ID of switch 1? Bridge ID is combination of two things, priority plus base MAC address, and by default priority is 32768. So bridge ID of switch 1 will be 32768 plus base MAC address is 0A. Base MAC address of switch 1 is 0A. Base MAC address of switch 2 is 02. B. Base MAC address of switch 3 is 0. C. What will be the bridge ID of switch 3? 32768 plus 0. C. What will be the bridge ID of switch 2? 32768 plus 0. C. Now you tell me which switch has lowest bridge ID. Which switch has lowest bridge ID? Switch 1. Because here you can say base MAC address is 0. A. Priority is same. Priority is same on every switch. So if priority is same, then they will check base MAC address, because bridge ID is combination of two things, right? And which switch will become root bridge? Switch which will have lowest bridge ID. And in one network only one switch can be root bridge. In one network, in one layered LAN network, only one switch can be root bridge. So you tell me which switch will become root bridge? Switch 1, because switch 1 has lowest bridge ID. So switch 1 will become root bridge. This is my root bridge switch 0A, 0B and 0C. Yes or no? This switch is root bridge. Now how switch 3 and switch 2 will came to know that switch 1 is root bridge? For that, STP will exchange some messages. There are two types of message in STP. First one is configuration BPDU. So STP message is called BPDU. BPDU stands for Bridge Protocol Data Unit. Bridge Protocol Data Unit. And we have two types of BPDU. We have two types of BPDU and STP. There are two types of message. You can say there are two types of messages in STP. First one is configuration BPDU. Configuration BPDU. And second one is TCN BPDU. TCN BPDU. We will discuss about TCN BPDU later. Let me discuss about configuration BPDU. Right? TCN use of this message TCN BPDU is whenever any change will occur in topology. Right? Whenever any change will occur in topology, then we will use TCN BPDU. We will discuss more about TCN BPDU later. Right? Now let me discuss configuration BPDU. What is the use of configuration BPDU? So configuration BPDU is used to elect root bridge. First use of configuration BPDU is to elect root bridge. So first of all, at initial time, every switch will think that I am root bridge. Every switch will think that I am root bridge. So switch 3 will forward their BPDU to switch 1. Switch 3 will forward their BPDU to switch 2 also, that hey, my bridge ID is 32768 plus 0C and I am root bridge. When switch 1 will receive BPDU of switch 3, switch 1 will came to know that no, you are not root bridge. I am root bridge because I have lowest bridge ID. Switch 1 will also send their BPDU to switch 3, and in their BPDU bridge ID will be what? 32768 plus 0A. So switch 3 will came to know that yes, I am not root bridge. Who is root bridge? So switch who have lowest bridge ID. So I am receiving one BPDU from a switch whose bridge ID is 32768 plus 0A, which is lower than my bridge ID. That means switch 1 is root bridge. I am not root bridge. And switch 3 will stop sending configuration BPDU. Right? After election of root bridge, only root bridge switch will send configuration BPDU. Non-root bridge switch will never send configuration BPDU. Right? So first of all, at initial, every switch will share their BPDU. Right? Every switch will think that I am root bridge, but on switch 2 and switch 3 will receive BPDU of switch 1. This switch will came to know that I am not root bridge. Switch 1 is root bridge. Now non-root bridge switch. Switch 3 is non-root bridge switch and switch 2 is also non-root bridge switch. So non-root bridge switch will stop forwarding configuration BPDU. It will never send configuration BPDU again. Only root bridge switch will send configuration BPDU after every 2 seconds. After every 2 seconds, root bridge switch will share configuration BPDU to manage the entire topology. Right? To manage the entire topology. Fine. Only root bridge. After election, only root bridge will share configuration BPDU. And what is the use of configuration BPDU? To elect root bridge and to maintain the topology, to maintain the loop free logical topology which is created by a spanning tree protocol, right? So first step is election of root bridge. Now hope it's clear to you that which switch will become root bridge. So here in this topology, guys, tell me which switch will become root bridge. So by default priority on every switch is 32768, right? And base MAC address is this one. So priority on every switch is same, so election will not happen on the basis of priority. Election will happen on the basis of base MAC address. So see, MAC address of this switch is lower than switch 2, switch 3 and switch 4. So switch 1 will become what? Root bridge. Switch 1 will become what? Root bridge. And if you want to make switch 2 as root bridge, what you can do? You cannot change base MAC address, but you can change priority. You will set priority lesser than 32768 on switch number 2. Then switch 2 will become what? Root bridge. Suppose if I will configure priority 0 here, so what will be the bridge ID of this switch? Bridge ID of this switch will be 0 plus base MAC address, this one. Yes or no? Now switch 2 have lowest bridge ID, so switch 2 will become root bridge. So first of all, switch will check priority. If priority will tie, then switch will check base MAC address, right? So switch with, if priority is default, by default on every switches, then root bridge election will happen on the basis of base MAC address, right? After that, once root bridge election will done, once root bridge election will done, router will elect what? This is my root bridge. This one is my root bridge. Yes or no? So after that, router will elect root port. So we have three types of port in STP. Port role in STP. We have three types of port role in STP. First one is DP, second one is RP, and third one is alternate, right? DP stands for designated port, and RP stands for root port. RP stands for root port, and alternate, ALT stands for alternate. And state of DP and RP will be in forwarding, and state of alternate port will be in blocking, right? So alternate port जो भी होगा उसका state क्या रहेगा? Blocking, right? And state of DP and RP will be forwarding. Fine. Now what is DP and what is RP, right? What is DP and RP? So to discuss what is DP and RP, you have to understand BPDU. You have to understand BPDU, Bridge Protocol Data Unit, because designated port DP is the port which will transmit best BPDU, or you can say superior BPDU. So we have two types of BPDU in STP, right? One is configuration BPDU and second one is TCN BPDU. And there are two types of configuration BPDU. There are two types of configuration BPDU. First one is superior and second one is inferior. First one is best and second one is which is not best. So how to identify superior BPDU, right? Once you will learn how to identify superior BPDU, you will understand what is DP and what is RP, because RP is a port which will receive superior BPDU and DP is port which will transmit superior BPDU. So you have to understand in this topology how many ports are sending superior BPDU, how many ports are receiving superior BPDU, and the port who is not sending superior BPDU or who is not receiving superior BPDU, that port will become what? Alternate, and a state of alternate port be blocking, right? So switch will not send any frame from alternate port, or switch will not receive any frame on alternate port which is in blocking state. Okay, so first of all understand BPDU. superior BPDU. How to identify superior BPDU. So topic is how to identify superior BPDU. Fine. How to identify superior BPDU. And you know what are the content in BPDU? Let me discuss what will be the content in BPDU first of all. See, suppose, or you can search here as well, content of configuration BPDU. Yeah, this one. Copy image and let me paste it here. I think it's not visible. Let me take another image. Leave it, let me write here. So content in configuration BPDU will be, first one is protocol. After that version. So protocol field will always 0. Protocol field will always 0. Version will also always 0. After that there will be information of type field. Type field identify that it is a which type of STP message, either configuration BPDU or TCN BPDU. Then in BPDU there will be one flag field. We will discuss about flag field as well later. Okay, then there will be information of root bridge ID. After that there will be information of cost, RPC, root path cost. Then there will be information of sender bridge ID, and after that there will be information of sender bridge ID, then sender port ID, after that max edge time, then there will be information of forward delay time, then there will be information of message age, and there will be one more information that is known as hello timer. By default hello timer is 2 seconds. So after every 2 seconds router will send BPDU message, right? Protocol field will be always 0, which will identify the protocol that it is an STP. So STP protocol number, STP is using which protocol number? 0, right? After that version will always set to 0. Then type field will identify which message it is. Either it can be configuration BPDU, or there are two types of BPDU, configuration and TCN. So type field will identify that it is an TCN BPDU or configuration BPDU, right? Flag field we will discuss later. And in root bridge ID, in this field there will be ID of root bridge, right? RPC, root path cost, will be total cost to reach root bridge. Suppose this is my switch 1 and this is my switch 2, this one is my switch 3. Suppose MAC address of this switch is A, MAC address of this switch is 0, B, MAC address of this switch is 0, C. So switch 1 will become root bridge, right? So switch 1 will forward configuration BPDU to switch 2 also and to switch 3 also. So when root bridge will generate BPDU, cost will be 0. Cost will be 0 because it is total cost to reach root bridge. So who is generating this BPDU? Root bridge. So cost from root bridge to root bridge is 0. Cost from root bridge to root bridge is 0. What will be the cost from switch 2 to root bridge? So it will add the cost of receiving interface. Suppose cost of this interface is 19, right? So cost will be 19 on switch 2. So this is RPC. RPC will be 19. Means distance from switch 2 to reach root bridge is 19. This is distance, right? And it will always add the cost of receiving interface. When switch 2 will forward this BPDU to switch 3, so when switch 3 will receive BPDU on this interface, switch 3 will also calculate RPC, total cost to reach root bridge, means total distance to reach root bridge. So when switch 2 will receive BPDU of switch 1, what will be the sender bridge ID? Sender bridge ID will be 32768 plus 0A. What will be the cost? Cost will be 0. What will be the sender bridge ID? Sender bridge ID will be 32768 plus 0A. Same, because this switch is root bridge. After that there will be information of port ID, sender port ID, right? When switch 2 will receive this BPDU, what switch 2 will do? Switch 2 will add receiving interface cost, and this cost is predefined. This cost is predefined. For fast Ethernet link, cost will be 19. For Ethernet link, cost will be 100. For Ethernet link, cost will be 100. You can check in Google as well. See STP cost. So see here, guys. So link whose speed is 10 Mbps, cost will be 100. Link whose speed is 100 Mbps, for that cost will be 19. Link of 1 Gbps, cost will be 4, and link of 10 Gbps, cost will be 2. So this is predefined value. This is predefined value. STP never reveal formula to calculate cost, but you can understand that cost is indirectly proportional to speed. More speed, least cost. So cost is inversely proportional to speed. I don't know what is the formula to calculate cost. Here you can see these are cost. For a link whose speed is 10 Mbps is 100. Link whose speed is 10 Mbps, for that cost will be 100, and link of 100 Mbps cost will be 19, right? Okay, so this is methodology: switch 1, switch 2 and switch 3. So switch 3 will receive configuration BPDU from two sides. Actually this one is my root bridge. Switch 2 will also forward configuration BPDU, and switch 2 will also forward. So it will receive from on this interface as well. So it will compare that which BPDU is best, which BPDU is superior, right? On switch 3, on which port I am receiving superior BPDU. So first of all, switch will check root bridge ID, then switch will check cost, RPC, total cost to reach root bridge. These are cost of port. So by default suppose this is my first Ethernet link, so cost will be 19, 19, 19, 19 and 19. And whenever root bridge switch will generate BPDU, it will add cost 0. When non-root bridge switch will receive that BPDU, they will add their receiving interface cost. So when switch 2 will receive this BPDU, cost will be what? 19. When switch 2 will forward to switch 3, when switch 3 will receive this BPDU on this interface, cost will be what? 38. 19 plus 19. Total cost is 38. Means distance from switch 3 to reach root bridge via switch 2 is 38. And distance from switch 3 to root bridge via this link is 19. So definitely I am receiving superior BPDU. Switch 3 will think that I am receiving superior BPDU on this port. Yes or no? Yes or no? Yes. And when switch 3 will send configuration BPDUs to switch, when switch 2 will forward configuration BPDU to switch 3, sender bridge ID will be changed, because root bridge ID will be same 32768 plus 0A, root bridge ID of root bridge, but sender bridge ID will be 32768 plus 0B and cost will be 19. So you have to understand here how switch will identify superior BPDU. Okay, so these are content of BPDU, configuration BPDU. These are content of configuration BPDU. Okay, now let me discuss how to identify superior BPDU. To identify superior BPDU, first of all switch will check what? First of all switch will check root bridge ID. Switch will check what? Root bridge ID. Then switch will check RPC, root port cost, total cost to reach root bridge. Then switch will check sender bridge ID. Then fourth thing, switch will check what? Sender port ID. Then switch will check what? Receiver port ID. And port ID is also combination of two things. Port ID, what is port ID? Port ID is again combination of two things: port priority plus port ID. Port priority plus port ID. Port ID is combination of two things. Let me discuss. Okay, so you can take one screenshot. This is how switch will identify superior BPDU. So to identify superior BPDU, first of all switch will check root bridge ID, then switch will check RPC, then switch will check sender bridge ID, then switch will check sender port ID, then switch will check receiver port ID. Fine. Now see STP port ID. STP port ID. STP port ID is combination of two things. First one is priority and second one is port number, or you can say port ID. Port priority is by default 128. By default port priority on average switch is 128 and port ID is port number. Suppose on a switch, this is my 0/0. So what will be the STP port ID of this port? 128.0, because this is port number. Okay, so port ID is combination of two things, priority plus port ID. Now suppose we have three switch 1, switch 2 and switch 3. Suppose MAC address of this switch is 0A, MAC address of this switch is 0B, MAC address of this switch is 0C. Now you tell me which switch will become root bridge. Switch number 1, this switch will become what? Root bridge. So this switch will send configuration BPDU after every 2 seconds. In configuration BPDU, what will be the bridge ID? 32768 plus 0A. Cost will be what? RPC will be 0. This is cost to reach root bridge from root bridge is 0. Then sender bridge ID will be 32768 plus 0A, same, because this is who is generating this BPDU? Root bridge. After that there will be information of sender port ID. So suppose this is 0/0, sender port ID will be 128.1. fine, and it will switch 1 will send to switch 2. When switch 2 will receive this BPDU, what switch 2 will do? Switch 2 will forward to switch 3. When switch 2 will forward to switch 3, what will be root bridge ID? Same, 32768 plus 0A. What will be the cost? Cost will be 19, right? Because switch 2 is telling to switch 3 that from me to reach root bridge cost is 19. You can calculate cost to reach root bridge by adding your interface, by adding your receiving interface cost, right? So switch 3 will add their receiving interface cost to calculate distance to reach root bridge. Now what will be the sender bridge ID? Sender bridge ID will be 32768 plus 0B, because who is sending this BPDU? Switch number 2. And what will be the port ID? Suppose this one is 0/0, this one is 0/1, 128.1. fine. When switch 3 will receive this BPDU, and there is one more switch, switch 4, it will forward to switch 4. So root bridge ID will be same, cost will be 38, and sender bridge ID will be 32768, and port ID will be the port ID of exit interface. Again switch 4 will add their on receiving interface cost, and then they will calculate total cost to reach root bridge. Now question is how to identify superior BPDU. Suppose a switch is receiving BPDU from two side, right? From two side. So first of all, switch will check what? Root bridge ID. So suppose this is 0/0 and this one is 0/1. This is 0/0, this is 0/1. Suppose on this port on 0/0 switch is receiving a BPDU where root bridge ID is 32768 plus 0A, and switch 2 is receiving BPDU on 0/1 also, but here root bridge ID is 32768 plus 0B. So which one is superior? This one. The switch 1 will came to know that I am receiving superior BPDU on which interface? On 0/0. But suppose if bridge ID is same on both interface, switch is receiving BPDU where bridge ID is same in both BPDU, then switch will check what? Cost. Then switch will check cost. Suppose here cost is 19 and here cost is 38. So which BPDU is superior? Switch is receiving BPDU on 0/0. That BPDU is superior because here cost is least. If cost will be same on both sides, suppose cost is same, then switch will check what? Sender bridge ID. And suppose here sender bridge ID is 32768 plus 0B, and here sender bridge ID is 32768 plus 0C. So superior BPDU is receiving on which interface? On 0/0. But again if sender bridge ID is same 0B, then switch will check what? Sender port ID. And if sender port ID is also same, then switch will check receiving port ID, and receiving port ID can never be same. How switch can receive two BPDU on same interface, right? So definitely receiving port ID will be different. Okay, so this is how switch will identify superior BPDU. Now come to my topology. See, this is my switch 1, this one is my switch 2, and this one is my switch 3. This is suppose 0/0, this one is suppose 0/1, this one is 0/0, this one is 0/1, this one is 0/0, and this one is again 0/1. Suppose base MAC address of this switch is 0A, base MAC address of this switch is 0B, and base MAC address of this switch is 0 C. Okay, fine. So which switch will become root bridge? Switch number 1. This switch will become root bridge. Now this switch is root bridge, so this switch will send configuration BPDU to switch 2 also and to switch 3 also. Fine. So who is sending superior BPDU? Root bridge. First of all, root bridge is sending superior BPDU, because let me talk about BPDU of switch 3. So switch 3 is not root bridge, right? Their BPDU is not superior. So always keep in mind that all ports of root bridge will become designated port, will become DP, because root bridge will send superior BPDU, because root bridge will send superior BPDU. So this port will become DP, this port will become DP. Am I right? Now let me talk about switch 2. Let me talk about switch number 2. Which port will become RP? Root port. So root port is that port on which superior BPDU will received. जिस पोर्ट पे superior BPDU receive होगा. So switch 2 will receive BPDU on how many port? On 2 port, on this port and on this port, on 0/0 also and on 0/1 also. You tell me on which port switch 2 is receiving superior BPDU. So switch 2 is receiving one BPDU on 0/0. In that BPDU, bridge ID will be what? 32768 plus 0A, and cost will be what? 0. Right? So it will add receiving interface cost. So here on switch 2 cost will become 19. But when switch 2 will receive BPDU on this interface on 0/2, on 0/2, what will be the cost? What will be the bridge ID? First of all, bridge ID will be 32768 plus 0A, and cost will be what? 19. Because switch 3, when switch 3 will receive BPDU of switch 1, right, it will add cost and then it will forward to switch 2. So switch 2 is receiving one BPDU on 0/1 where cost is 19, and it will add their own cost, that is 19. So total cost will be 38, and here total cost is 19. So switch 2 is receiving superior BPDU on which interface? On 0/0. So this port will become what? RP. This port will become RP. And always keep in mind that only one RP can be there on one नॉन रूट ब्रिज स्विच. एक स्विच के ऊपर में एक से ज्यादा आरपी नहीं हो सकता है. देयर कैन बी नॉट मोर देन वन आरपी ऑन अ सिंगल स्विच, otherwise loop can form, because RP is the only port with the help of that port switch can reach to root bridge. Right? Now tell me which port will become RP on switch 3. So in the same way, switch 3 is receiving BPDU on 2 port, on 0/1 also and on 0/0 also. But on 0/1 it is receiving inferior BPDU, and on 0/0 it is receiving superior BPDU. So this port will become what? RP. This port will become RP. Yes or no? Now let me talk about this segment. So which port will become DP? Because on switch 2 and switch 3 there can be at least one RP, and RP election is already done, right? So definitely this port will not become RP. Either this port can become DP or alternate. This port will become DP or alternate. So you have to elect that which port is DP. So what is DP? Designated port which is sending superior BPDU. So tell me which port is sending superior BPDU, this port or this port? So when this port will send BPDU, root bridge ID will be 32768 plus 0A. In the same way, when switch 2 will forward BPDU from this interface, root bridge ID will be bridge ID of switch 1. After that, cost will be 19 here also, and cost will be 19 here also. Then switch will check what? Sender bridge ID. So sender bridge ID of switch 2 is, root bridge ID of switch 2 is 32768 plus 0B, and bridge ID of This is bridge ID of switch 2 is 32768 plus 0B, and bridge ID of switch 3 is 32768 plus 0C. So switch 2 is sending superior BPDU, switch 2 is transmitting superior BPDU. So this port will become DP, and this port will become alternate, because rule is there can be not 2 DP on same segment and there can be no 2 RP on same non-root bridge switch. Rule is on one segment only one DP can be there, right? And on one non-root bridge switch only one RP can be there. Fine. So now in this topology, you tell me which switch will become root bridge. Here, this is my topology. Which switch will become root bridge? Or let me design topology here. So this is my switch 1. This is my switch 2. This is my switch 3, and this one is my switch 4. There are 2 links. Okay. Here also we have suppose 2 links. Okay, and between switches again we have 2 links. Okay, fine. Suppose this is my switch 1, MAC address of this switch is 0A, MAC address of this switch is 0B, MAC address of this switch is 0C, and MAC address of this switch is 0D. Now you tell me which switch will become root bridge. This switch 1, switch whose MAC address is 0A, because his bridge ID is 32768 plus 0A. His bridge ID is 32768 plus 0A. Bridge ID of switch 2 is 32768 plus 0C. Bridge ID of this switch is 32768 plus 0D, and bridge ID of this switch is 32768 plus 0C. Yes or no? So definitely this switch will become root bridge. This switch is my root bridge. So all port of root bridge will become DP, because root bridge will always send superior BPDU. Root bridge will always transmit superior BPDU, and DP is port which transmit superior BPDU. वो पोर्ट जो सुपीरियर बीपीडीयू ट्रांसमिट करता है उस पोर्ट को हम डीपी बोलते हैं, राइट? सो ऑल पोर्ट ऑफ दिस स्विच विल बिकम डीपी, 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 डीपी एंड डीपी, right? And let me give number port ID as well. Suppose this is my 0/0 link, this one is my 0/1 link, this one is my 0/2 link, this one is 0/3 link, this is 0/4, and this one is 0/5. In the same way, on every switch, this is 0/0, this one is 0/1, this one is suppose 0/2, this one is 0/3, this one is 0/4, and this one is 0/5. In the same way, this one is 0/1, this one is 0/2. Fine. Now on switch 2, on this switch, which port will become RP? Which port will become RP? There can be only one RP, yes or no? There can be only one RP on a single non-root bridge switch. So which port will become RP? So guys, first of all, understand switch B. This switch will receive BPDU on this port as well, on this port as well, right? On this port as well, on this port as well, right? So on which port switch 2, switch 0B is receiving superior BPDU? So see, when this switch will receive BPDU on this port, cost will be what? Cost will be 19. When switch 2 will receive BPDU on these two port, cost will be what? Cost will be 19 plus 19, 38. On switch 2 will receive BPDU on these two port, what will be the cost? Cost will be 19 and plus 19, 38. So definitely switch 2 is receiving superior BPDU on these two interface, yes or no? Switch 2 is receiving superior BPDU on these two interface. So out of these two interface, one port will become what? RP, right? So switch B is receiving BPDU on this port also and this port also. First of all, they will check breeze ID will be same on both port. Then they will check cost will be same on both port. Then they will check sender breeze ID, so sender breeze ID will be same on both port. Then they will check sender port ID, so sender port ID will be list on this interface. So this port will become what? This port will become RP. This port will become RP and this port will become blocking, alternate, because on this segment there is one DP, right? There is one DP, so this port will definitely become alternate, and a state of alternate port will be blocking. Fine. On switch C, which port will become RP? On switch C, which port will become RP? So switch 3 will also receive BPDU on this port, on this port and on this port, right? So here on these two port it will receive with least cost 19. So out of these two port, one port will become RP. Which port? This port, 0/4. Sender breeze ID will be lower on this port, so this port will become RP and this port will become alternate, because there is already DP on this link, right? And there can be no more than one DP on same segment. So on this segment there is already one DP, so definitely this port will become alternate, because RP is already available on this switch. There can be not more than one RP on a single switch. Fine. Now we need to find RP on this switch. So this switch will receive BPDU on these two port also, on these two port also, and on these two port also. On these two port, cost will be 38, because 19 here and 19 here. Total cost will be 38, right? In the same way, on these two port, cost will be 38, and on these two port, cost will be 19, right? So out of these two port, one port will become what? RP. So which port will become RP? This port, 0/2. This port will become RP and this port will become alternate. Yes or no? Because on 0/2 it is receiving superior BPDU because of lowest sender port ID. Because of lowest sender port ID. Fine. Is it clear? So here, move it. This port will become RP and this port will become alternate. Fine. Now RP election is done on every switches, right? Yes or no? Now you have to elect DP. You have to elect DP. Automatically alternate port will block. Alternate port will be blocked. You don't need to elect alternate port, just you need to find DP. Definitely adjacent port will become alternate, right? So see here guys, on this segment, on these two segment, which device, which switch is sending superior BPDU? To find DP, you have to identify that which port is sending superior BPDU. So tell me these port are sending superior BPDU or these port are sending superior BPDU. So when switch 2 will send BPDU from this interface, and when switch 4 will send BPDU from this interface. So here root bridge ID will be same in both BPDU. After that cost will be same. Cost will be same because here you can see cost will be receiving interface cost. This one is RP, right? So cost will be 19. Then they will check what sender bridge ID. So sender bridge ID is lower. Which switch have lower sender bridge ID? Switch 2. So these two port will become what? DP, and definitely these two port will become what? Alternate. On this segment, which switch is sending superior BPDUs? Switch C, switch 3, because of lowest sender bridge ID, right? So these two port will become DP, alternate. On this segment, which switch is sending superior BPDU? This switch B, right? Because of lowest bridge ID. So these port will become DP. These two port will become alternate. Yes or no? This is election criteria of root bridge, designated port and root port. Fine. So now suppose here is one user and here is also one user want to communicate with each other. Suppose IP address of this machine is 10.1, IP address of this machine is 10.2, right? So traffic will be go via root bridge. Which path will be used by these switches to forward traffic of 10.1 to 10.2? So see which path will use. This is block port. Port roll of these port are alternate, right? So this will be in blocking state, right? This is DP, but these are block ports. So switch will never learn any MAC address on DP port, on this port. Yes or no? Switch will never learn any MAC address on this port because switch 3 will never, switch 0C will never receive any frame on these two interface, because blocking port cannot send or receive any frame. Yes or no? So it will, switch 3 will use this port to forward frame. So traffic will be reached to switch 1, to root bridge. After that, root bridge will forward to switch D, right? It will forward to switch D. Yes or no? Because definitely switch A will learn MAC address of this machine on this interface on 0/2. So it will forward to switch D and switch D will forward to your machine, right? When this machine will generate reply, in the same way reply will come like this. Yes or no? My question is, my requirement is, whenever this user want to communicate with this user, traffic should go like this. Go like this. My traffic should go like this. What will you do? What will you do? You have to make this port as RP and this port as DP, or this port as DP and this port as RP. So if you are thinking that I will make this switch as root bridge, do it guys, do it. First of all, try to solve this question by yourself, right? But if you have any problem to solve this question, please let me know in comment. Definitely I will make one video on it, right? Definitely I will make one video on it, that how these two users will communicate like this from switch 3 to switch 4, or they can communicate like this also, they can communicate like this also, right? So it's depends on requirement. What is my requirement? Okay, so if you have any doubt, please let me know in comment. If you don't have any doubt and if you have learned something from this video, please don't forget to like this video. Please hit on subscribe button. We will meet soon in next video. Till then, stay safe guys. Bye bye.